Good evening, students. So now we are going to study about capacitance of a parallel plate capacitor with a dielectric slab. Students, firstly we have studied the capacitance of a capacitor in vacuum. Okay, and because I don't have this space on the board, so I am just explaining it. So for a capacitor, we calculated the capacitance and the capacitance was epsilon naught A upon D. What was A here? A was the area of cross section of the capacitor and D is the distance between the two plates. Okay. And how we increases the capacitance of a capacitor? So earlier what we did, we just firstly we kept one plate, okay, and when we kept one plate, then there was a very high electric field and we wanted to decrease the potential. That is why we just brought one more plate, and when we brought one more plate by the method of induction, this plate was negatively charged and this plate was positively charged. And for further reducing the potential, what we did, we just made it grounded, and when we made it grounded, all the positive charge were gone out and the potential was decreased. And because of the decrement in the potential, the capacitance was increased, and finally we got the capacitance of a capacitor epsilon naught A upon D. Okay. Now students, we want to further increase the capacitance. Now is it possible that we have a capacitor and we want to increase its capacitance more? Okay, because we want more and more. So we want to increase the capacitance of a capacitor. Then we found a very great solution, and the solution is just to introduce a dielectric material between the plates of the capacitor. We have a capacitor, we have two plates of the capacitor, okay, and we are introducing our dielectric slab between the plate of capacitor. So suppose this is a dielectric slab and we are introducing it between the plate in such a way that it is occupying the volume between the plates. Okay, so this is how we are introducing a dielectric slab between the plates of capacitor. So forget about this dielectric slab firstly. Okay, let us understand this without the dielectric slab, that what was the condition earlier. So earlier when a capacitor we have, okay, and we have charged it. How we have charged it? The answer is that we have applied the potential difference, and because of the potential difference, this surface has accumulated all the positive charge, and suppose the total charge gained by this surface is plus q, and by the method of induction, the another plate of this capacitor will occupy the charge minus q. Fine. So what should be the capacitance of this capacitor? Okay, what is the medium right now? Which thing we have introduced in the beginning? The answer, we have introduced nothing, so we can say vacuum is there in between. Okay, so vacuum is present. That is what I have written. The capacitance of a capacitor, plate separation D with vacuum between the plates. So there is vacuum between the plates. And what is the capacitance? Epsilon naught A upon D. We have proved it. Now, initially, what is the electric field? We have calculated the electric field due to one plate, okay, by application of Gauss theorem in first chapter, and that was E naught is equal to sigma upon epsilon naught. What is E naught? Students, E naught is the electric field which we are applying actually. So E naught, E original we can say, okay, is equal to sigma upon epsilon naught. Now what is the value of sigma? Sigma is the charge density, okay. Total charge is Q, in cross section suppose is A. So the charge density will be Q upon A. So sigma upon epsilon naught, this will be Q upon A epsilon naught. Fine. Now students, we have introduced a dielectric slab between the plates of capacitor. Firstly, we will try to understand that how a dielectric slab can increase the capacitance of a capacitor. So this dielectric slab we have filled inside, and what is the meaning of dielectric slab? That there are materials, dielectric materials inside it. So when dielectric material is there in there, it is present in the presence of electric field. Then what is the effect of what is the effect on the dielectric when it is kept in electric field? I have explained in one video yesterday, and I told you that the dielectric will get polarized. It will get a dipole moment. So this is what is happening actually. You can see electric field is present. So because of the electric field, the negative electron, okay, negative charge of that will be going in the opposite direction of field. So negative will be separated, positive charge will be separated out. In the similar way, all negative charge will accumulate in the opposite direction of the field, and positive charge will be accumulated in the direction of electric field. So this is what exactly is happening. So now what is the benefit of it? The benefit, if we think about, the total electric field is, the total charge is still zero. We will say the number of protons are equal to number of electrons, the net charge is zero. But by the logic, you should understand one thing, that the surface charge is not zero. You can see that all the surface charges present, all the positive charges are accumulated here. So suppose QP charge is Q. Why I am writing P? Because this is a charge which is we are getting because of polarization. When a dielectric material is kept in electric field, then this method is known as polarization. So this is charge because of polarization. And all the negative charges accumulated on another surface, okay, and suppose this is minus QP. So students, one thing is very clear to us, that this particular surface is offering a high potential and this negative is indicating the low potential. So what is the direction of electric field? We already have studied, when there is one electric means higher potential and lower potential, then electric field is introduced, then electric field direction will be this. And what should I write this? I will write it EP. Why I am writing it EP? Because this electric field is introduced because of dielectric slab. Now students, we can correlate it now that we have studied for capacitance. When we were increasing the capacitance, our first headache was to decrease the electric field and to decrease the potential. So now you can see clearly that one electric field originally was from here to here. E naught was in this direction, okay, from left to the right. And this EP is right to left. So these two electric fields are opposite in direction. So there will be reduction in electric field and there will be reduction in potential. And if there is reduction in potential, then obviously there will be increase in the capacitance. So this is a very great solution. If you want to increase the capacitance of a capacitor, just introduce the dielectric slab between the plate of the capacitors. Okay. Now students, this is what we have done. So initially the electric field was E naught is equal to sigma upon epsilon naught. So Q upon A epsilon naught. Fine. Now, what is the induced field? This is the induced field I have told you. Okay, so this will be sigma p upon epsilon naught. Why sigma p upon epsilon naught? Because the charge is due to polarization. So suppose the surface charge density is sigma p here and minus sigma p here. So what is the electric field? That will be sigma p upon epsilon naught. What is sigma p? Surface charge density due to polarization. One thing which we have studied, that sigma p can be replaced by p. Okay, polarization density. Okay, dipole moment per unit volume was numerically equal to sigma p, surface charge density. If you don't understand this, this is because you haven't watched the previous lecture before. So please watch it, you will understand this. Sigma p, surface charge density, is numerically equal to the polarization density. So I am replacing this sigma p by p. Okay. Now what is the net field inside the dielectric? So the net field will be E naught is working here originally, EP is working here. So the net field will be E naught minus EP inside the dielectric, E naught minus EP. Now students, we already have studied one thing, that was dielectric constant K. Dielectric constant K is given by E naught upon E naught minus EP. So this dielectric constant was the ratio of the original electric field to the net electric field. Okay. So by this we can understand one thing. If you calculate the value of E naught minus EP from here, E naught minus EP will be how much? So E naught minus EP will be E naught upon K by this relation. So the net field inside the dielectric will be how much? E naught upon K. What is K here? K is the dielectric constant of the material, means dielectric slab which we have introduced. I hope you understood this. Now, the potential difference between the plates. What is the formula for potential difference? We know only one formula. If electric field is given to us and we are calculating potential, then the formula for potential is V is equal to E into R. electric field into distance, that how much longer distance the electric field is working. Now students, in this particular case, we are very confused that which electric field actually we have to consider. We have to consider the original electric field, that was E naught, or we have to consider the electric field EP. So the answer is very clear. Where the dielectric material is not present, in T thickness it is present, total separation is D. So where the dielectric is not present, answer is total minus T thickness you have to subtract. So in D minus T thickness, the dielectric material is not present. Okay. So in this particular area or in this particular length, D minus T length, which electric field is there? The total electric field is there. Okay. So in this particular, the electric field is E naught. Okay. So E naught into D minus T. I have told you the formula. V is equal to E into R. So here I am telling you in D minus T, the original field is present. So D minus T, distance into E naught. Fine. Plus, now which electric field we should consider inside the dielectric material? So inside the dielectric material, we should take the net electric field. That is the difference of the original field E naught and EP. So here we will consider E naught minus EP. Okay. But E naught minus EP, we already have calculated the value of E naught minus EP, net electric field. That was given by E naught upon K. So here we are substituting E into T. Firstly, we are writing because T is the thickness and E is the net electric field. And what is the value of net electric field? We have calculated the value of net electric field, that was E naught upon K. So let us substitute this in the next step. So V will be E naught D minus T plus E naught upon KT. Now you can see that E naught is common between all. So E naught we have considered common. Here will be D minus T plus T upon K. Now students, what is the value of E naught? We already know that electric field for a capacitor will be Q upon epsilon naught A. Okay, this formula we have studied. If you are confused, then this formula you already have studied. That what is the value of E? The value for E is equal to sigma upon epsilon naught. Okay, sigma upon epsilon naught, where sigma is the charge density. When you will substitute the value Q upon A, you will get Q upon A epsilon naught. Okay, so in place of this E naught, we are writing Q upon epsilon naught A, D minus T plus T upon K. Then what will be the value of capacitance? Capacitance C will be how much? Capacitance is the ratio of charge and potential. So we have done both the things. Charge we already know. Potential we have calculated overall. Okay. So let us substitute this Q upon V. So Q will remain Q. So Q upon, in place of V, what is the value? Q upon epsilon naught A D minus T plus T upon K. Now this Q and Q gets cancelled out. Epsilon naught A is in the denominator to the denominator. This will be shifted to the numerator. So this will be epsilon naught A upon D minus T plus T upon K. That's a little complicated formula, but you have to learn it. Okay. So this is the proper derivation. If the dielectric material is not present, then what is the capacitance of a capacitor? C is equal to epsilon naught A upon D. And if the dielectric material is present, then because this thickness will be affected by the extra means polarized field, then the net electric field will be reduced and the capacitance will be increased. Why it will be increased? As you can see, this subtracting terms, these all subtracting terms are in the denominator. So if denominator will be less, the overall value will be greater. Okay. So capacitance we have increased. Now, suppose we are considering one special case when T is equal to D. What is the meaning of this? T is equal to D. So the meaning of T is equal to D is that the thickness of the dielectric slab which we are going to introduce between the plates of capacitor is suppose is equal to the thickness, means total separation between the plates. T is equal to D. That overall, what is the total separation? D. And this is what we are introducing, the same width dielectric. So what will be there? Let us substitute the value. So C is equal to epsilon naught A upon, in place of T, there will be D. So D minus D plus D upon K. D and D, because both will be subtracted, 0. So we will get K epsilon naught A upon D. What is epsilon naught A upon D? That is the capacitance of a capacitor. So initially, without the dielectric slab, the capacitance of the capacitor was, suppose I am writing it as C naught. So it is C naught. So we can write epsilon naught A upon d as C naught. So K C naught. Now what is the ratio of C and C naught by this relation? That is equal to K. Because C naught is here in multiply, shifted there in divide. So K is equal to C upon C naught. And if you remember my previous video, this is what I was explaining to you. So dielectric constant is actually telling us that how many times the capacitance of a capacitor is increased when we are introducing that particular material. So more will be the dielectric constant for a material. That is better for us because it will increase the capacitance by this much number of times. I hope you understood this. Thank you. God bless.